right. Well, let's get started. I see there's still some people coming in, but yeah, thanks everyone for joining us today. For those of you that aren't from Sudbury or aren't familiar with the SPDA, this is the Sudbury Prospectors and Developers Association, which usually has these in-person monthly meetings where we're getting together to discuss new exciting exploration stories and look at some rocks and some networking, and of course with what's been going on in the last year, we decided to start these virtual ones, and we've already had a few really good meetings this year. So today we got a very exciting story lined up. Kenorland made one of the most significant discoveries in Quebec last year, gold discoveries. We also like to acknowledge our sponsors. So we started a corporate sponsorship that will help us to put these virtual meetings on and record them and make them available. So we're very thankful that we already have 3 sponsors. Noront, which was of course the presenter of the last in February, where we had Ryan Weston present on the Ring of Fire, which was a very popular presentation, and it's already online as well, so people can access it. And the other sponsors are Exiro Minerals, which is based in Sudbury, and their project incubator, very interesting business model, and we'll actually have one of our next talks will be from them, so we'll hear all about that. And then other sponsors, Jacob and Samuel Drilling, which is a Sudbury-based drilling company, and I only have the highest praise for their work, an excellent drilling company. So yeah, if you're interested in sponsoring these virtual events, we'd be very happy if you could help us out. And yeah, so let me introduce Francis MacDonald. He's the Vice President of Exploration for Kenorland, and he joins us all the way from beautiful Germany in Munich. So it's a bit late there already around this time, but I think he's excited enough about his projects that he's going to be able to stay awake. And Francis, yeah, Francis has been with Kenorland for a few years, I think since the inception. It's a fairly new company, and they just went public, actually, I think a couple of weeks ago, if I'm not mistaken, at least last month. And yeah, they got very interesting, very exciting exploration projects. As I mentioned, the discovery already in Quebec last year was one of the most significant discoveries. And apart from just that discovery, what really fascinates me is their exploration strategy and methods. So I think it's going to be a very exciting talk, and I'm very much looking forward to chatting with Francis afterwards on their approach. And yeah, before joining Kenorland, Francis was with Newmont for quite a few years, working in Africa and in different North American projects. So yeah, with further ado, Francis, please, well, first of all, welcome, and please go ahead and share your screen.
So Attila gave me a good introduction, and so he had asked me to talk at this about the Regnault target that we're currently drilling right now, which is in our Frotet project in Quebec. But he was also kind of asking about exploration strategy, and was kind of asking some questions leading into, how did we get to this point of finding something new in a fairly well explored region in Quebec. So this talk it's going to talk about a bunch of things, and it might jump around, but it'll talk a little bit about strategy and some of the drilling compilation study that we did last year, which I think is really interesting and gives perspective about initial drilling. And then I'll also talk about 2 of our other projects that we're going to drill this summer, which have similar themes, as their big greenfields exploration projects that hopefully will deliver similar results to our Frotet project in Quebec. So as Attila said, so I'm Executive Vice President of Exploration for Kenorland and one of the co-founders. And Kenorland started in 2016. We were a private company up until January 4th, 2021. So we have been operating privately with joint ventures, currently with Sumitomo and one with Newmont, and we've had previous joint ventures with Freeport-McMoRan as well. So that's just a little introduction, and I'll jump into it. The standard disclaimer, don't take it as an investment advice. And then an additional disclaimer. So a lot of the data in this, when we'll talk about the drilling data, is from a disparate sources. So government reports, assessment reports, academic papers, press releases, 43101s, Northern Miner articles, basically anywhere that made reference to the initial drilling into things. So don't take this as 100% accurate. You know, we did our best to try and find the primary data, but there might be errors or inconsistencies in this data set. So I'll just start out really high level and just looking at gold in Canada. And so this is looking at all the greater than 2 million ounce gold deposits in Canada. There's 83 across Canada that are greater than 2 million ounces. And so these are gold deposits with gold as the primary commodity, so filtering out copper porphyries. And so if you use a 2 million ounce cutoff, there's approximately 650 million ounces of gold endowment in Canada. And these are spread across, or the majority is hosted in 6 geologic domains. So that's these ones on the map: the Slave, the Golden Triangle, the Uchi Birch, Wawa Wabagoon, Southern Abitibi, and the Northern Abitibi. And so those 6 geologic domains host 87% of the endowment. And of those domains, 5 of those are Archean greenstone belts. And so Archean greenstone belts host 75% of the gold endowment in Canada. And so just from an exploration strategy perspective, you know, if you stay in Archean greenstone belts and you're looking for gold, then that's a pretty safe place to be. And then the Golden Triangle hosts about 18% of the endowment. So that's quite a special place up there with about 118 million ounces of gold. So when you take all of these 2 million ounce deposits, I've grouped them in 3 different categories. And so this would be greenfields, 3 different categories of discovery. So greenfields, brownfields, and historic. And so I'll start out with historic. So these are deposits that were discovered early on by prospecting in northern Canada. So this would be things like the Timmins Camp or Kirkland Lake that were discovered pre-1950-ish by someone going out with a hammer, with, you know, banging off a piece of a quartz vein that was outcropping, and then they started just sunk a shaft and started mining. So these would be the historic ones. Brownfields, we all know what this is, but a deposit that's found around a significant gold deposit. An example of that would be Canadian Malarctic, where there was historically about 5.5 million ounces of gold produced, and then Osisko went in 2005 and found another 20 million ounce deposit. And then there's greenfields. So this is obviously where no gold deposits have been found historically. An example would be Eleanor, 2004. That was discovered in a completely new area by tracing a glacially transported boulder back to the source. So when you break all of these into these categories, it's roughly equal percentages. So equal number of deposits and about equal number of ounces. And so I guess the takeaway from that is that greenfields, there's slightly more greenfields exploration ounces overall. And so there's a lot of endowment that's been found from greenfields exploration in Canada. So when we look at these by decade, obviously the historic deposits are found in the kind of pre-1950s era, which is kind of where I would say modern exploration started. And so after 1950, this is after World War II, you know, we're starting to fly airborne geophysics. You know, there's geochemistry starting to happen. And so we have a few deposits that are discovered in the 60s and 70s, and then in the 1980s it really exploded. And this is probably due to the initiation of flow-through financing in the 80s, and a lot of money was started to be funneled into gold exploration, but also the gold price spike in the 1980s as well probably fueled that. And then from the 1980s, the number of significant greater than 2 million ounce deposits has decreased decade by decade. From 1980 to 2000, there was 22 grassroots discoveries that were made. And then from the year 2000 to 2020, only 5 grassroots discoveries. And so why is this? We all talk about discovery rates going down, and I would say greenfields discovery rates are especially going down in the last 30 years. And in general, I think this is because greenfields exploration has been underfunded relative to brownfields exploration. So this is probably one of the most important slides out of this study. And this is the initial drilling, or the best intersect of the initial drill program that I could find in all of these deposits. And so this is talking a lot about GT, and so this is basically grade times thickness. And so if you have a 10-meter interval that runs 10 grams per ton, it's 100 GT. So this one probably takes a while to look at to see where all of the deposits are on this, because there's quite a few. But the range obviously varies quite a bit. But I think when you plot everything up, you can start to look at it statistically, look for some kind of patterns. One easy way to look at this is the median is 134 GT, and a lot of the significant greater than 5 million ounce gold deposits have greater than 100 GT intersects on the initial program. The 80th percentile of all these 2 million ounce deposits is a 75 GT hole on the initial program. And so there's some areas in here, some deposits in here that are, surprises, like the Amaruk discovery in Nunavut by Agnico I think it was a 74 GT hole. So, this could be 8 meters at 9 grams or something like that. The Hope Bay Madrid deposit, so this would have been right on the edges, but the initial drilling into Madrid was a 25 GT intersect, and that turned into a 5 million ounce deposit. So obviously you can't write anything off, but it is interesting to see what the initial drilling looks like into these deposits. So diving into that a little more, this is plotting up the GT intersects versus total gold endowment. And it's quite a range, obviously, but there's a few kind of conclusions that you can make from this. And so the majority of 2 million ounce deposits have initial GT intersects of greater than 50 GT. So if you hit 5 meters at 10 grams on an initial drill program, that's similar to a lot of these other deposits that have been found. And then the majority of 5 million ounce gold deposits have greater than the median GT, like I was saying. So, greater than, let's say, 130, 134. So this is kind of just a rule of thumb and patterns that we see from the positive cases. And obviously there's lots of drilling out there where you hit a good drill intersect that doesn't turn into a deposit. But we'll dive into that a little bit after this. So I think this is probably one of the more important metrics as well. And this is the total gold endowment versus the intersect thickness, or of the mineralized rock in the initial drilling. And so in gold deposits these days, we're usually mining between 1 and 10 grams per ton. So that's one order of magnitude, but the tonnage is really what can vary quite a bit. And so we can have, 2 orders of magnitude difference on the tonnage. And on an initial drill program, the tonnage is obviously proportional to the volume, and the only dimension that we get of volume on a discovery drill program is the thickness of that mineralized interval. So when you plot all these up, most of the 5 million ounce deposits have greater than 10 meters of mineralized rock on the initial drill program. And most of the 2 million ounce deposits have greater than 5 meters of mineralized rock. So that's not taking a 50 centimeter vein and spreading it over 10 meters. That's, there's 10 meters of rock that's mineralized. And so that's kind of a rule of thumb of just looking at these significant discoveries in Canada. And this is obviously geared more towards structurally controlled deposits rather than big low-grade porphyry deposits as well. So this is going back to the GT plot and all of the deposits associated with those GT intersects. Our Regnault target sits right here. So on the initial drill program, we intersected 29 meters at about 8.5 grams gold, and that was a 247 GT intersect, and that included 11 meters of about 18.4 grams gold. There was no historic drill holes and no mineral occurrences in this area, so this is a completely greenfields discovery. And so comparable drill intersects on initial drill programs would be the Coffee deposit in the Yukon and Canadian Malartic in Quebec. And this is, I should note, this is a joint venture with Sumitomo, and so we are advancing the property in a JV right now. So that's a lot about the initial drilling to kind of set the context, and so I'll kind of go into more of the property scale about the Frotet project. And on this map, this is all of Kenorland's claims in the Abitibi Greenstone Belt, which is the second biggest gold producing district in the world. We're the largest landholder in the Abitibi, and we have joint ventures with Sumitomo at our Frotet project, which is up in the northeast, and our Shikabee project, which is around Amos here. Joint venture with Newmont on our Shabistawan project, and then our O'Sullivan project and Hunter project are 100% owned that we're advancing ourselves. So we're quite busy, but I'll be talking about the Frotet project today, which is in the northeast here in the Frotet Evans Greenstone Belt. And currently it covers about 40,000 hectares of the Frotay Evans Greenstone Belt. Kenorland staked this in March of 2017. And so the entire Frotet Evans Greenstone Belt was wide open at that point. And we had done a whole bunch of stuff. We were looking around in the Abitibi. We ran a prospectivity model, and it kind of turned our eyes up there, and we said, well, the Troilus deposit produced 2 million ounces of gold. There must be something else in that belt. So we staked originally 56,000 hectares up there. And so that's really, our kind of modus operandi, I guess, in the last years has been look for geologically prospective areas with low exploration maturity and acquire through map staking. So geologic or exploration maturity, I think, is a big part of it. And this map is a drilling density map of the Abitibi. And so areas that are lighting up have obviously seen a lot of drilling in the past. And so what we're looking at is we're looking for areas that have a low exploration maturity, because if we're doing greenfields exploration and someone has gone in there and really drilled the piss out of it and hasn't found anything yet, what are the chances of you going in there and drilling a few more holes and all of a sudden making a discovery? So we're in terms of greenfields where we can go out and map stake without known resources, we're really looking for low exploration maturity areas. And the entire Frotay Evans Greenstone Belt has a really low drilling density. And so that checked a box for us there. So jumping into the property scale, simplified geology map of the Frotay Evans Belt with our claim package. So typical Archean greenstone belt, it's a bit older. The Troilus diorite, which is up here, which the Troilite deposit is right on the edge of it, I think has an age of about 2780, so a bit older than a lot of the Abitibi. And it's a kind of typical greenstone belt where we have multiple cycles of tholeiitic to calc-alkaline volcanism and magmatism. And after, in the last couple weeks, we've just realized that we're getting even subalkalic magmatism. So the intrusion that hosts the Regnault target is actually a monzodiorite and is kind of trending into the alkalic space. So far, we've identified 4 target areas for additional exploration. So, and all of them are undocumented and never been drill tested. So the Regnault area, so this is the highlight where we made the initial discovery last year. So this is high-grade gold hosted in a multi-phase intrusive complex. The Cressida area is up here in the north, so that's right on trend of Troilus Gold's southwest zone and really on the Troilus trend as well. And it's got an extensive gold in till anomaly that hasn't been drill tested yet. The Châtillon area is on the north side of this this intermediate to felsic and volcanic package, and that's about 1 kilometer by kilometer of mineralized and altered boulders with grab samples up to 22 grams per ton. No drilling in that area. And then up at La Fourche, also on the contact of that calc-alkaline intermediate to felsic volcanic package, there's a 1.6 kilometer by 1 kilometer bismuth, tungsten, tellurium, moly, cesium, thallium, potassium, and a whole bunch of other element anomalies. So no drilling up there either. And so the Regnault area is really the only place that we've done any drilling so far to date. This is a mag map of the Frotay Evans Belt. And so I think the most important things here are that you see a couple trends. And in the south part of the property, you see this east-west trend fairly well in the mag. You can see it out here as well off of our claim boundary. And so right where the Regnault area is, this big east-west structure takes a big jog and comes up into our property. And so the intrusive complex is emplaced into that jog. And that structure goes out to James Bay. So it's really a first order 300-kilometer long structure, and we're kind of sitting right on a complexity in that structure. And then the other trends that you see are this northeast trend, and we think that's probably an earlier deformational phase. And Troilus sits up in the northern part on one of these big east-west trends up here. So this is a simplified Surficial geology map of the Frotay project. And so the green on this map is glacial till. And so that's been really important for us, and probably the most fundamental exploration tool that we've been using is till geochemistry. We acquired all of this data, and we looked at the surficial conditions. You can see in the DEM that there's some really nice streamlining out where you can see the DEM. And so we know that the glaciers are moving things around, and there should be glacial dispersion in the area. And so the goal of this was to use the till to look for a dispersion plume, which is effectively making your target bigger. And the bedrock is probably, what we're looking for might be 10 meters wide, but the till dispersion plume, when the glaciers smear it across the landscape, could be kilometers wide. And using those concepts, and which has been used extensively in Canada, we just applied that to the Frotay Evans Belt. And I think one thing that is kind of different these days is the detection limits. When people did a lot of till exploration in Canada, the detection limits were quite high. But at this point, we're using, we're getting 0.1 ppb detection limits on a 50-gram aqua regia. So the signal versus background is really detectable these days. And so I'll go to the next slide to talk a little bit more about this. So this is the initial sampling grid that we did on these wider space lines, and the line spacing on these is 1.5 kilometers, and the sample spacing is 150 meter sample spacing. We did this in 2018 and covered the entire 56,000 hectare property at that point. And after we completed that grid, we dropped some claims because there was no gold on them. And then in 2019, followed up in four areas with tighter grids with about 4,000 samples, taking the sample spacing down to 250 by 100. And so obviously on this map, the Regnault area sticks out the most. And just to go back to the detection limit point, the Regnault area was defined by 3 lines, and I think it was a total of 6 samples. And there was 1 sample above 50 ppb gold, and I think 3 between 25 and 50 ppb. So the grid that we laid out, we were really looking for big stuff, and it worked. We filtered out a lot of little stuff, and we you can see in some of these areas, like the northern part of the Chantillon area, it looked good on the initial grid, but it doesn't look so good now. Whereas the Cressida area obviously got bumped up quite a bit. So we infilled down to a 50 meter by 50 meter spacing in the Regnault area because we knew we were onto something down here. And so just to reiterate again, there was no historic mineral occurrences ever recorded and no historic drilling. And so, what we did here was just look at a greenstone belt. We said, this is prospective because it's got a plus 5 million ounce deposit in it, and there hasn't really been any systematic geochemistry done. And so this is kind of where we got to. So in that soil anomaly, which is about 5 kilometers long, we went in and started prospecting. And so we started finding boulders. There's absolutely no outcrop. We had 15 geologists out there looking for outcrop, and we didn't find any. But what we did find was boulders. And we started, smashing boulders open, zapping them with the XRF, and we're getting gold and XRF even. And so this is what the boulders look like. We collected about 140 boulders in the area. 10 of them were over 10 grams per ton with a max of 408 grams per ton. And 43 were over 0.1 grams per ton. So, the statistics are pretty good. There's a lot of gold in a lot of rocks here where we're sampling. So the gold was found in a number of different styles. So there's quartz vein only, then there's quartz veining within this diorite, and then there's disseminated sulfidized felsic tuffs, which have up to 5 grams gold in them, and we haven't intersected that yet in the drilling to date. So we know it's out there somewhere. So when you cut these boulders open, this is what we knew what we were looking for. So it's got 1 to 5% disseminated pyrite associated with this veining. The veining could be sheeted veining or stockwork veining in different places. And so I think this was really fundamental to the drilling discovery because we knew the physical properties of what we were looking for in bedrock. So we knew the lithology was a diorite. We knew we had disseminated sulfides, and we knew it was structurally controlled and vein hosted. So that kind of gave us some parameters to look for in the geophysics when we got down there. So this is plotting up all of our geochemical data sets. And so you can see the boulders on the right here. So there's a big cluster of plus 10 gram boulders in this area. And then there's another cluster up here of lower grade, but we ended up drilling some really high grade bedrock up there. Since that program, we acquired all of this southern ground down here. So this wasn't included in the original sampling grids. We acquired this from O3 mining last year, and then continued the sampling grid down to the south. So this area hasn't been drill tested at all yet. And the gold in the tills keeps going down to the southwest here. So there's no historic drilling down here either. In this area, the ice direction is towards the southwest, but the structural trend is also southwest. So we're not really sure how much of this is dispersion and how much is in bedrock. And so that's really what we're going to be trying to sort out. Starting in 2 weeks, we'll be drilling down there. And what we did also was run gold grains. And so this is using the iOS gold grain counting methodology, and they're a lab out of Quebec. And so we're getting up to 400 gold grains with 75 to 80% of them being pristine. We have a big cluster of pristine grains in just off the side of this lake here where we've drilled, but then we also see the pristine grains picking up down ice on these southern claims where we haven't drilled at all yet. So I think we're pretty confident that we're going to hit something down there. We have gold and boulders trending down there as well. So we've basically just drilled under boulders because we don't think they move very far, and we've been hitting high grade gold and bedrock. So I think that bodes well for the southern area down there. Just a little bit about the geology. So this is the current interpretation, and we are just in the beginning stages of this. Like I said, there's absolutely no outcrop in the area, and so what we know so far is that the gold is hosted in what we're calling this diorite, which is actually a monzodiorite, and it's an intrusive complex with at least 4 different chemical phases in it, and it's quite complicated. There's porphyry dikes all over the place and a number of different chemistries that we see. So we're really starting to just get a handle on the lithological story right now. So far, gold has only been intersected in this diorite, and so that's obviously one of our main targeting criteria, is that we're sticking close to this prospective lithology. When you look at the mag where we've drilled, so up in here, which is what we're calling the Regnault discovery area where we've drilled to date, it's really a mess in the mag. And we have some kind of interesting features, these blue dots in here that looks like magnetic lows. They're actually magnetic highs, but they're remnantly magnetized. And so we're not quite sure what this means yet, but it does seem like there's a spatial association between these remnantly magnetized phases and the contacts, and their contacts, and where we're finding gold. And so I think, in the mag, you can see that there looks like there's probably intrusive rocks that continue down to the southwest here too. So we're going to be sorting that out on this drill program, of kind of defining the footprint of how big the system is, which I think is really fundamental at the start, and which is, I think, something that Great Bear has done really well, is just kind of define the footprint and keep stepping out early. So looking at the drill results, the best intersect was up in here on the edge of the lake. So that was the 29 meters at 8.5 grams. We tagged the structure on this hole. The grade wasn't as good, and we came underneath it on this hole. So I think we've sorted out that the structure is dipping this way out into the lake. So we're coming back and drilling up across it this time. Up here on the northern parts, we hit 2.6 meters of about 10 grams. There's also these low-grade intercepts of 25 meters of about 0.27. On the western side of the lake, we hit 2.66 grams of about 33 meters, 2.66 meters of 33 grams. Down in the south, the best intersect so far is 3.75 meters at 16 grams. And we have a whole bunch of gold intersects all over the place. This hole hit, a meter of 13 and a meter of 17. So we're not really sure anything yet, in terms of how many structures we have, the geometry of things. It's, we don't really have much to go off of here in terms of geometric targets. And so we're really just scout drilling at this point, of poking around until we can define some geometry. The other thing to note on this map is the scale. So from this intersect down to the south, it's 2 kilometers. And so we've been hitting gold over 2 kilometers, multiple structures, probably half a meter or half a kilometer across so far. And, we're continuing drilling to the south, hoping that we'll kind of extend it to about a 4-kilometer footprint. So this is the original chargeability from the IP that we did. This was a 200-meter line-spaced IP survey, and this is chargeability 75 meters below the surface. So areas of moderate chargeability within the intrusive rocks, this is where we've hit all of the gold so far. And so the chargeability works really well because we're dealing with intrusive rocks. There's no graphite. It doesn't seem like magnetite is really charging. And so we've really been kind of leaning on the chargeability for the drill targeting. And we are completing a 50-meter line space 3D IP survey right now, and we've got about 75% of that survey completed. And so that's really been a big push in the last couple months. And just getting that data that we need for the drill targeting. And so we are just about finished that. So this is what the drill core looked like on that 29-meter intersect. So there's a couple things in here to note. So the wall rock is running significant gold. So we're getting 9.1 grams per ton in this sample. There's very little quartz veining here, so that could indicate that we could build tonnage quickly. And then also the highest grade sample in this whole interval was 50 grams per ton. So it's not like there's 1,000 gram per ton sample that's carrying the whole interval. It's really well mineralized across the whole thing. In terms of the alterations, so we see biotite and calcite and disseminated pyrite, similar to what we've seen in the boulders. So in terms of geologic summary, what we know so far, the host rocks, the intrusive rocks are the only place that we've intersected gold to date, but we know there is gold in the volcanic rock somewhere because we have boulders that have gold that are volcanics. From lithogeochemistry, we've defined a number of different diorite or monzodiorite phases within the Regnault intrusive complex. And veining and mineralization is typically around and along internal contacts within that intrusive complex. So structure and mineralization style, so it's a high-grade gold hosted in quartz calcite veins. The veining occurs in stockworks, sheeted veining, or massive veins. The wall rock has significant gold associated with disseminated pyrite. And we just got some petrographic work done by Peter Thompson, who I saw pop his head in to the call. And so the gold is in sulfides quite a bit, and it's also where we see chalcopyrite. We always see chalcopyrite, I think, with the gold a lot of the time, but when we see visual chalcopyrite, that's when we get really high grades here. And in terms of trace element geochemistry, there's basically a 1-to-1 correlation between gold, silver, and tellurium. And so we have some unidentified mineral phases that occur with chalcopyrite and gold, and they're probably tellurides. And then we have weaker correlation between bismuth, moly, tungsten, silver, and copper. I guess just one other thing about the tellurium. So we're getting really high grade tellurium. It's really 1-to-1 with gold. So we're getting up to 600 grams per ton tellurium, which is really high. So that's really unusual. That's the kind of tellurium numbers that you see around Kirkland Lake. So it's definitely unusual. And the other thing is that the gold silver ratio is highly variable. And so typically in orogenic gold deposits, gold is greater than silver, but here we're getting a lot more silver than gold. And it does vary to gold greater than silver in some places as well. Alteration, I've mentioned this, so it's really biotite calcite. That's ubiquitous around mineralized zones. The geophysical properties, so chargeability within the intrusive rocks. This has produced all of the best drill intersects. Chargeability within volcanic rocks has produced no significant gold so far. So that's obviously one of our targeting criteria is stay around the chargeability within the intrusive rocks. And then remnant magnetization, these certain phases, which have a distinct chemistry as well, it seems like there's a spatial association with gold and these remnant magnetized bodies. In terms of paragenetic sequence, from what we saw in the core, visually, it looked like mineralization was fairly early. It's quite deformed. The quartz veins are quite recrystallized. And we are kind of digging into that a bit more in the petrography right now. So just to bring it back out to the Quebec scale and look at if this is significant or not. This is looking at the whole Quebec CIGIOM drill database, which has 156,000 drill holes in it from assessment reports in Quebec. And so drilling that's filed in assessment reports is really a record of the early days of exploration, because once companies have enough credits on their claims, they don't file assessment reports a lot of the time. And so this records early stage exploration a lot of the time. And so the idea with this is let's look at the entire Quebec drill hole database of early stage exploration results and look at what's really significant and see if we can, is there false positives in this 134 GT metric, and how does the Quebec database compare when you look at it in terms of GT? So this is everything in Quebec, 156,000 holes. And so I've plotted the intersect length on the x-axis and the GT intersect on the y-axis, and just kind of put these metrics that we saw from the Canadian gold discoveries, more than 2 million ounces. So 134 GT here and 10 meters of mineralized rock here. And so this upper quadrant is really where you find a lot of the deposits, the greater than 2 million ounce deposits in Canada. And so this is the Regnault drill intersect on that first pass program right here. So obviously it's plotting quite high up and is probably very significant compared to the rest of the drilling in Quebec. And so when you plot these up by deposit areas, so these are some significant deposits in Quebec. So Canadian Malarctic in red, you can see out here has the longer intersects. Fenelon, which had very significant historic drill intersects before, is plotting up in this quadrant, and Attila and Walbridge have been finding lots more there. And so the Windfall is another one. So the orange are these Windfall ones. So they were plotting high. And so those holes were from pre-Cisco days too. So there was good indications that there was a big system there early on, I think. And so Regnault, this is the intersect up here. So obviously it's plotting up with all of these major deposits in Quebec. So that's why we think that this is quite significant and has potential to be very significant. And obviously this is early days, but we're always trying to make decisions based on the data that we have at the time. And we have to live in the early days and make decisions based on having very little data. But the data that we have so far, I think, shows that it's quite significant. And so what we're doing right now, we are doing an IP survey over this whole yellow block down to the southern edge of the claims. So it's 125 line kilometers of IP, and that should wrap up in about 10 days. We are drilling on the lake right now, so following up on areas where we've hit gold so far and testing a bunch of new targets. We'll be moving. We just finished the drill planning today for this next area down in the south, so we'll be moving there next week. And then we'll continue drilling the Regnault South area, which has seen no drilling at all so far. And so we've kind of allocated about 3,000 meters to each of these areas. So I think it's going to be a really exciting year on the Frotet project, and stay tuned. And so I'm going to take this opportunity to talk a little bit about the other projects that we're drilling as well, which are also early stage exploration projects. And Kenorland is either the majority or owns these projects 100%, and we'll be drilling these starting in June this year. So we'll finish up at Frotet and then immediately move over to Alaska and just keep the news flowing in terms of early stage drilling results. So this is our Tanacross project, which is sitting right here. It's on the border with the Yukon on the Alaska side. And so it's in the Yukon-Tanana terrain, which spans across a lot of central Alaska and down into the Yukon. This terrain hosts porphyry deposits like the Casino deposit. So Casino sits down here in the Yukon. So that's a 2 billion ton deposit. And it sits right at the intersection of this arc parallel structure, or origin parallel structure, which is going northwest, which is the Big Creek Fault, and this origin perpendicular structure going northeast, and that's the Dip Creek Fault. So that structural setting is repeated in Alaska, which is where the Tanacross project sits. It's at this intersection between northeast and northwest, or origin parallel and perpendicular structures. And so just to illustrate that in this schematic, this is from Cam McQuaig and John Hronsky. These origin perpendicular structures, they can form in a bunch of ways. This might be rotation because of differential movement on the Tintina and Denali faults. But they're long-lived structures that get reactivated over time, and they're a really good place where they intersect with other structures to put porphyry deposits. And so there's lots of this been documented in Chile, and we're sitting at one of these big intersections here. So looking at the mag, I think on the mag you can see these things. So you can see this Dip Creek structure coming in. The Big Creek fault comes up through here, and then you see all these kind of magnetic units up here, which are a lot of intrusive rocks. There's quite a bit of structural complexity all over the Yukon Tanana, and I think that's what's controlling a lot of the emplacement of these intrusions. And so we're kind of sitting right on this big magnetic anomaly at the intersection of those two structures there. So another thing that we do, so this is the upward continued magnetics data. And so what we're upward continuing all of the mag across the area to kind of look deeper and bring out these more these deeper magnetic signatures. And so the Tanacross project is sitting on this big deep magnetic feature, and on the bottom right here, so this is Tanacross here, and this is Pebble at the same scale, also upward continued 10-kilometer upward continued mag data. And so the interpretation of this is that we have a big oxidized intrusive batholith at depth, and we're getting porphyries that are coming off of that. And there's a good paper by Eric Anderson in southwestern Alaska that plots up porphyry occurrences on upward continued mag data, and they're all kind of sitting on these big batholiths. And so we think that there's a big batholith underneath Tanacross and that there's porphyries coming off of it. So zooming into the property scale, the land package is also big, so it's about 400 square kilometers. The geology is similar to the Casino area. It's late Cretaceous porphyries, and there's a number of porphyry centers on the property. We have a number of age dates on these. They all come back at about 69 to 73 MA, which is similar to the Casino area. The thing that gets us really excited about this property is the alteration footprint, and that there's about 30 square kilometers of alteration. On this map, it's this black outline, so it kind of spans about 10 kilometers in an east-west direction. We've digitized a lot of alteration footprints around big porphyry deposits and also the ore body footprints as well. And so that's what this map is down here. So you can see the scale of alteration around these major porphyries. You know, they have big alteration footprints, but when you compare it to the Taurus Bluff alteration footprint, I think that you can fit a major porphyry deposit in that alteration. So in terms of historic drilling, we're not just arm waving here. There's a known porphyry on the property. There's historic drilling with up to 239 meters of 0.3 copper, 0.23 gold, and 0.036 moly. We stepped out from that in 2019 in a JV with Freeport and hit 276 meters of 0.23 copper, 0.16 gold, and 0.036 moly. And so Freeport funded about $5 million US in exploration up here, and then they ended up pulling out around COVID times just because they were getting hammered on their stock price, and exploration basically got cut. So we got the property back, and one of the fundamental data sets that we're using is a ZTEM survey, and that was flown the same time we were drilling. So all of the targets that came out of the ZTEM survey were not tested, and so that's what we're going to go up this summer is test some of those targets. The East Taurus area, this is where the known porphyry is. There's a big soils anomaly at West Taurus. We drilled some holes and didn't find much. And then Bluff is another porphyry center where we've hit a kilometer of phyllic alteration, but we haven't found the center there yet. On this map, on the right-hand side, so this is a Ridge Spur soil sampling program that we did, and this is in the Yukon Tanana terrain. There's no glaciation up here. And so we were pulling rocks out of the soil pits and just kind of mapping them as altered, unaltered, or unknown. And so this is a really rough proxy of alteration, but you can see in this area that there's extensive alteration in the rocks that we pulled out. And then the gridded image in the background is a sericite index from the soils. And so this is something that Pim Van Geffen did for us. And so it's also kind of showing that there's a proxy for alteration in this South Taurus area. So looking at the South Taurus area in the magnetics, or sorry, in the geophysics, zooming into this area, you can see that there's this discrete mag high in here. We go over to the Z10, which we didn't have when we were drilling, but you can see that that mag high lines up with this resistive core in the center, and then there's this ring of conductivity around it. And from what we've seen so far, it looks like the conductivity is really mapping the QSP alteration. And then when you go down in wavelength and look at the deep, or sorry, the 30 hertz, so the long wavelength, we're looking kind of a 1.5 to 2 kilometers down. There's a big conductor on there, so there's something special about this area. And so when you look at this and kind of put it in context, this is the South Taurus area. This is sitting right in the 30 square kilometers of alteration, and this is the Z10 at Pebble at the same scale, so it's the same signature. There is a resistive core with conductive QSP, a conductivity ring of QSP alteration around it. When you cut a section through South Taurus, this is what it looks like. So there's this deep conductivity along this, what's probably a structure. This is a section through Pebble, and it looks exactly the same. So you have a deep conductivity, and you have it's structurally controlled on that side of the deposit. So we're going to go out and drill some holes into this year, and there's a few targets around the East Taurus porphyry system that we're going to go drill as well this year. So that's the Tanacross project. And then the other one in Alaska is our Healy project. And so this is to the southeast of Pogo, and it's about 18,000 hectares of state-owned land. We're in the Tintina Gold Province, and so big deposits are Fort Knox, Pogo, Coffee, Scheelite Dome, and Dublin Gulch. And so there's been past production of about 30 million ounces, so we know it's a really well-endowed area. So in terms of geology, so the Yukon Tanana is a kind of interesting geological setting. The Pogo deposit is up here, so approximately 10 million ounces of endowment. The Goodpaster district within the Yukon Tanana, so it's an orogenic terrain of upper Paleozoic and older supercrustal rocks that extends from central Alaska down to the central Yukon. And so the deposits in the Yukon, so Golden Saddle, Coffee, Freegold Mountain, all of these deposits would be in similar rocks. So Healy represents a completely new gold system that was identified by Newmont through a systematic stream sediment sampling or BLEG sampling program in 2011 over all of central Alaska, so approximately this big red block. So it was really a huge area, and they BLEG sampled the whole thing. And the Healy area was one of the best anomalies that came out of that entire survey. So Newmont worked it up for a couple of seasons up to a kind of coarse soil grid, and then exploration kind of got the axe. They cut all helicopter exploration for a few years, and this went on the shelf. And so we were able to acquire this from Newmont in 2018. So zooming into the property scale geology, so on here you can see there's a number of trends. So there's these steep north-northeast trending structures, and then you can see that there's these more shallow thrusts that have slivers of ultramafics around them. And so within the area, we're kind of sitting on this regional contact between Cretaceous intrusive rocks and metamorphic rocks, which are probably metasedimentary rocks. And that's kind of a regional setting of where Pogo is hosted as well, so similar geology. In terms of the structures, we have, like I was saying, there's the steep north-northeast and then the shallow thrusts, and this is a similar story around Pogo and the Noosi gold deposit as well. And so we have gold anomalism that's associated with both of those structural trends. So we picked up where Newmont left off. They did the ridge and spur grid that you can see on here. and infilled with some of the grid sampling as well, and then we really kind of infilled it. So there are a number of areas here. There's up to 2 kilometer long gold, arsenic, antimony in soil anomalies. So it's quite big and extensive, and I'll show some comparables to kind of illustrate that in a bit. So this was in Northway Resources, and we originally did an RTO with Northway to list recently. So this is how this has kind of come into Kenorland. So zooming into that area, so in 2019, we carried out a small reconnaissance RC program, and we only got 800 meters out of it. It was a bit of a kerfuffle with the drill contractor and crossing borders and things like that. So we drilled some really short holes up in this area, and we hit 49 meters at 0.42 grams gold. So we know there's a big disseminated system up there in this small area. We probably tested about, I would say, 300 meters of strike. So we probably have another 1.7 kilometers to test in that anomaly. And then so we have a number of anomalies that haven't been drill tested at all yet that we're going to go up and drill this year. In 2020, we infilled the soils to 50 by 50 meters. We did a high-res mag survey. We did a detailed ground mag over the area, and we did a VLF survey on these targets. And we also did IP over all the soils anomalies as well. So VLF has worked really well in this area, especially at the coffee deposit at defining structures. And it's really what we've been told, a silver bullet there of really picking out the structures, and I'll show a little bit of that in a minute. And so I think after this program, we've collected a lot of surface data over a couple of years, and we're at the stage of going up there and putting the initial diamond drill holes into a lot of these targets. So this is the VLF that I was talking about with the soil anomalies on top. So you can see the VLF, it really picks out the structures. I think we have really good control on where the structures are within those soil anomalies. And when you plot the soil anomalies on the VLF, it looks like they're right on top of these on top of these VLF conductors. So I think what's going on is that it's probably water percolating down these damage zones, and we're probably getting the conductivity out of the water here. But whatever it is, it maps the structures really well. We also ran IP, like I was saying, across all of this, and we're going to drill about 4,000 meters up here, testing those targets. And just to look at one of the target areas, so this is the spike and trig anomaly. So this is the VLF with the soils on top of it. You can see that it looks like the soils are just shedding down slope off of this VLF anomaly. And then when you look at the charge, it's setting right underneath the VLF. So, obviously we're going to aim for that. And what we saw in the original drilling was disseminated sulfides with gold. So, we think that that chargeability with gold and VLF anomaly on top is a pretty good drill target. On the bottom here, so this is a section from Pogo. And so on this section, you can see these kind of shallow angle thrusts that have shallowly dipping veins. And a lot of the gold is in those shallowly dipping veins. And then there are steeper structures here as well. So we are obviously testing the low angle thrusts as well, because it looks like we have gold associated with them, and it would be a similar structural story to Pogo. And so to kind of put this in perspective, this is the soils data from Healy on the left-hand side. And then we've digitized all of the soils data that was collected by Sean Ryan and co. in the Yukon. So we have about 300,000 soil data points from the Yukon in our database. And so this is coffee in the center, which was discovered by Kamenak, I guess about 10 years ago now, and sold to Goldcorp, and 2.7 million ounces defined. That's the soil anomaly at coffee. Golden Saddle, so that was originally Underworld Resources, and then has ended up in gold, or sorry, in white gold again. So there's about 1.6 million ounces in that area with that soil anomaly. And so when you compare that to Healy, which is in similar rocks, similar terrain, and similar surficial conditions, it really looks like it's a significant soil anomaly that's comparable to Coffee and Golden Saddle. And so these are all at the same cutoffs at the same scale. So I think they're really quite comparable. So I think it's going to be a really exciting year up in Alaska this summer as well. At Healy, we're in the right geology. We're on this contact between intrusive rocks and the metamorphic rocks. We've employed a similar kind of systematic geochemical exploration to get here, or Newmont has done it, and we've kind of picked up where they left off. It's totally greenfield, so there's no historic exploration been filed, and there was only a small claim package here that was filed after the Pogo discovery, but it was dropped the year later and no work was filed. So we think that there's never been any work done in this area. It's got a large-scale geochemical footprint comparable to Coffee, Golden Saddle, and we know that there's gold in bedrock from the shallow RC drilling that we did. And so 2021 is the initial drill test up here. So that's our early stage drill programs that we're doing. There's about 4 or 5 other properties in the portfolio that I didn't talk about because it would be a very long talk, but we're working those up in the background, and we have about 500,000 hectares of ground in the portfolio that's all being worked up in the background, but those are the 3 targets that we're going to drill this year. And just to kind of summarize everything, and I know Attila wanted to ask some questions about exploration strategy, I thought I'd just kind of put this out there, and just in terms of how we're thinking about this. And it's not rocket science, but I think it's just kind of the thought process that goes behind some of this. So there's really, I think, 4 things that are important to think about: where to explore, the strategy of how you go about things, how to explore, so the tools that you use, and then recognition of success when you actually do find something. So where to explore, it's quite simple. Look in geologically prospective areas that have low exploration maturity. And so geological fertile areas, there's tons of studies that have been done on this, tons of research, and it's, and there's a lot of GIS and prospectivity, machine learning, all of this kind of stuff that's done. This would be the detailed approach. There's lots of arguments about this. You could find another area that's similar to Carlin up and down the west coast of North America, but it's not in Nevada, and so the Abitibi is also a special place because there's been so much gold found there already, so there's something special. So you can do a detailed approach using genetic models, prospectivity models, or the really simplistic approach is if there's significant deposits in similar rocks, then obviously the area is fertile. And then exploration maturity, I think that this is super important and a lot of the time is kind of overlooked. Understand what's been done previously is obviously the most important thing. This is kind of why Nevada scares me, just because I've never worked there and it's hard to find information. Look in areas that previous explorers haven't looked. It's pretty simple, but if you go back to the same areas and there's been 5 companies that have done the same thing, your chances of success on a greenfields exploration program are probably pretty thin. And then look different ways than previous explorers have looked. Also pretty simple, but it happens a lot of the time. And then also look undercover. I think all the major discoveries are going to happen undercover in a greenfield setting. If there was an outcropping major deposit, it would have been found decades ago. In terms of the strategy, so start out with a large area. I think that's like one of the more important things for greenfields. It's like greenfields exploration is like trying to find one needle in 10 haystacks. And so how do you deal with this? Don't choose one haystack, just explore all of them. And you'll find the needle if you have the right methods. So starting out with hundreds to tens of thousands of square kilometers is a really good strategy at the start. And I think the traditional adage that we've all heard that one project in 1,000 becomes a mine is pretty misleading, because the size of the project is what really matters. If you have 1,000 projects that are 1 square kilometer, then yeah, 1 in 1,000. But if you have one project that's 1,000 square kilometers, then you have a much better chance of success. And we should be thinking about screening prospective areas that haven't been hit hard before. And then basically every stage of these greenfields programs is area reduction. So each phase should be whittling it down a bit more, getting to that initial drill target. So how to explore the tools, this is all simple, but I'll just talk about it a bit. I think there's 5 choices. So geochemistry, geophysics, alteration, favorable lithologies, and structure. I like geochemistry and alteration best because it's a direct confirmation that there's metal in the system. But then also, if you have no mineralization, using geophysics, structure, and lithologic associations to extrapolate from that known mineralization can be super powerful, which is what we're doing at Tanacross. And so obviously the area reduction has to be tailored to the exploration tools that you're using and also the exploration environment, which at Frotet was a till-covered terrain with glacial dispersion. And just on that note, so the original survey of Frotet was planned because the structure is parallel to ice direction. And we said, okay, we want to find a mineralized body in outcrop that's probably 1 kilometer long. And we're going to guess that there's 2 kilometers of glacial dispersion off of that. And so if we have kilometers, so that's basically a 3 kilometer target. And we plan the lines to be 1.5 kilometers apart, so that we have 3 lines on top of a 3 kilometer target. And that's basically exactly what we found on the initial survey. And then recognition of success, understanding that you have something when you actually find it. And this is kind of going, it could be the till sampling programs, understanding signal versus background, understanding the signatures of major deposits that have been found in that way, I think is really important. And then also all of this stuff that we talked about with the drilling. And so there's been a lot of deposits that have been found after the 2nd or 3rd round of drilling. They've hit marginal results on the 1st round, and one of those deposits would be the Troilus deposit. I think it was the initial drilling around Troilus, it was a 30 GT intersect to the southwest of the actual deposit. But Rob Fraser decided that was very exciting and went back and found zone 87 the next year. So, understanding when you're in the ballpark is really important. Understand the footprint, geometry, and scale of these big deposits. So comparables, case studies, exploration history. And then the big question is when to continue and when to walk away. And obviously that's one of the biggest and hardest decisions to make. On average, out of all of the greenfields discoveries that I looked at in Canada, it took 3 passes of exploration, which included surface work. So that's kind of the rule of thumb in the positive cases. So it does take a number of years. And then, I think when we have more data, we make better decisions, which is kind of why we've been putting a lot of time and effort into this kind of thing. So that's it. And I'll pass it back to Attila to open up.
Thanks, Francis. No, this was an excellent summary of. I think people get a really good idea of the smart exploration that you guys are doing, and really is sort of the systematic exploration approach that I think we can kind of state without exaggeration here that like it's not very typical in the private space like you guys were, and even in the junior explorer space to have this sort of a long-term vision and working several years on a large land package to finally put the first holes into the ground. So just kind of picking up on that a little bit, and I'll encourage everybody to put in questions in the chat so we can address those as well. But so, what do you think? Where did this approach come from, or what enabled your team to have this long-term vision? What helped you your background, I guess, from previous companies. And so can you maybe talk about the team a little bit, and how it came about that you have this systematic approach?
Sure. Yeah. So before this, I worked with Newmont, and Zach, who's the president and CEO, worked with the Ivanhoe Group. And obviously, Ivanhoe has a long history and track record of doing big scale exploration programs, finding new deposits, and Newmont also does big scale exploration programs. And so I think it's really the philosophy that came from those two groups of this is kind of how you do it systematically.
Yeah.
Yeah, in terms of, we were a private company, and we staked the Frotet project in 2017, and we attracted Sumitomo. We signed a deal in 2018, and we hadn't done any work ourselves on the property yet. So, I think that was, and probably and is one of the strengths of Kenorland, is we're able to put the story together with the exploration approach, and show that we can kind of come to a conclusion, cheaply and quickly, or we can come to some kind of conclusion with an exploration program.
Yeah. And then, so what drove the decision to go public now? And do you think any of the exploration strategy is going to change a little bit now with the day-to-day market pressures, or what do you think the benefits of being public, and maybe some of the downsides that you might be facing from now on?
Yeah, I guess the decision was basically when we hit the drilling, the first drilling intersects at Frotet, and we were a private company. We had raised $3 million in the company over 3 years, and we brought back in about $3 million as well. We were kind of break even from cash payments and share payments and stuff. But we said, like, who's going to keep financing a private company at the valuation that we want to do it at? So to basically get a better valuation and less dilution for ourselves, and all of our shareholders at that point, we said, I think this is probably a good time to go public now that it looks like we could have something significant. And then in terms of the day-to-day, yeah, things have changed a little bit, obviously, because there's a whole other basket of things to worry about now.
What's the basket case, people? Yeah, exactly.
Yeah. But in terms of the strategy, I don't think it's going to change that much. What's going to drive the share price? It's like doing good work, coming up with new targets, drilling them, hopefully making more discoveries.
Yeah.
And
well, I think, like, you definitely have a really good track record in that now, and you've demonstrated that the smart sort of long-term approach where you do grid samples and then you sort of zoom in into, and it might take you 2 to 3 years, and like that's the thing that you got to live with the fact that some people might not have the patience to wait for 3 years to get a drill hole result. But I mean, you already have the track record that this is successful, and this is kind of how you have to explore these places that are covered with this much overburden. Like, you can't just go in there and start drilling holes, because that's pretty expensive. And so I think it's a really good testament, or case study to this type of approach, where you can do a lot of the more I guess cheaper or more cost-effective exploration on a larger scale first, and then you can zoom into areas. And I mean, if I saw correctly, your first drill program was 6,000 meters.
Yeah.
And and I mean, right away you're getting into 200 something gram per ton, grams meter intersection, plus some other ore grade intersections over 2 kilometer length. So it's definitely, so it looks like this model could be, you have 2-3 other projects that you've shown us now that where you're using the same approach, and chances are you're gonna get into something there as well. So
Yeah, I think it's about target development. You can, I think in general, this is my opinion. Maybe I don't want to offend anyone, but I think in Canada we've been too focused on mineral occurrences and outcropping rock. Whereas in Australia they don't have rock, and they have to come up with geologic models. They have to do things more systematically. There's big cover sequences that just drill through to get some kind of chemical signature on a grid. And if you go into these areas and just focus on mineral occurrences and step out, a lot of the time it's not going to be like, how do you rate and rank these mineral occurrences? Maybe 2 kilometers down the road there's something better that's never been discovered before. Unless it's given a real systematic shake. I think it's really hard to rate and rank things.
No, and that's an excellent comment, and yeah, I've talked to other people about that too. That we tend to get, some of these occurrences are almost like distractions because you click some moss and there's a nice gold vein right on surface, and it's hard to not get excited about that, and then you keep drilling or trenching in the same area. But if you zoom out a little bit, yeah, maybe that's just a tiny portion of a much larger system. Maybe you're not even on the main structure, or you're not even on the main part of the system. But after one owner after the other, they keep beating the same rocks to death, and Swiss cheesing the same small showing, rather than looking at it a little bit more globally and like, where is the best potential here, and maybe a kilometer over that's all covered, the overburden is where I should be focusing more a little bit.
Yeah, exactly.
So that's really good. And yeah, so maybe we were a bit spoiled here in Canada that we had places like Timmins and Kirkland Lake right on surface, and for 100 years we didn't really have to come up with a lot of creative exploration methods because it was right there. And in Australia, they had to deal with these kind of issues already 50, 60, however many years ago, coming up with creative exploration methods, right?
Yeah, and I think exploring around the known camps is probably still going to be productive. There will be, but probably declining productivity as you go. There's been a big push by the majors in brownfields exploration in the last probably 2 decades, and it hasn't really resulted in kind of putting ounces into the pipeline. Marginal amounts of ounces probably, but not a lot of huge discoveries, I think.
Yeah, there's a few majors that are pretty smart, like Agnico does some pretty good grassroots exploration, and some others. But yeah, kind of on that note, so who do you think should be the companies doing grassroots exploration? Should it be us juniors and prospectors, or should the majors step up a bit more? And I mean, you seem to have quite a bit of success with attracting JV partners, so obviously there is appetite from majors to fund junior exploration or like grassroots exploration, but they don't really do it themselves, right?
Yeah, I think it depends on the company and the time. Like Newmont has done a lot of greenfields exploration. I was working in Ethiopia on a huge, we had 30,000 square kilometers of Bleg survey, vectoring into the best 7,000 square kilometers and then vectoring in from there. So I think they're doing it. And so who should do it? Everybody.
Yeah, that's a good answer. Yeah.
Yeah, I don't know. I mean, I guess it depends on the people that you have, and it's been a great working relationship with Sumitomo and Newmont so far, and I think that model works really well.
Mm-hmm.
And it's good. Some people don't like the project generator model, because you give up a lot of the upside early on, but people don't think about all the risk that you give
You
up
also
as
share
well.
the risk. Yeah, exactly. So
Yeah.
I mean, these large soil sample grids and all that, and I mean, even just this drilling study that you've put together, to have people working on digitizing all this stuff and creating these materials, like, it's not you can't do that from just going out and raising $200,000 or something like that. You have to have somebody backing you that has this kind of a long-term vision. So yeah, I guess it's really good that you have Sumitomo, who seem to be sort of a patient partner that way. And so yeah, I guess your approach is bringing in partners quite early, right? So you wouldn't, is there any project that you would take yourself forward, and like you believe in it so much, and you're gonna raise some money on it?
Yeah,
And
well, that's the Healy and Tanacross projects that we're gonna
okay,
drill ourselves this summer.
yeah,
So, I think we're kind of looking at. I think it takes a portfolio approach. We need a pipeline of projects because maybe we'll go up to Alaska and we'll kill both of those projects. So the idea is that this summer we're also working up, the 5 other projects in the pipeline that I didn't talk about, potentially to drill stage, so that we have some more kind of organic growth in the pipeline, coming up to drill stage.
so and then maybe moving on to a little bit that discovery study, and I really enjoyed that. And for those of you who maybe haven't seen that before, this was just a really quick summary of it, I guess, just some of the slides. There's a much bigger version of that. I think it's online, right? There was a podcast that you gave.
Yeah.
So even that study itself is much bigger than this. And it's very impressive, nice, basically compilation of all these discoveries. And so, and not just because you gave Fenelon a plug, which I thank you for that, but it's really a good study. And so, yeah, like how would you define, so when you did this, like how do you define discovery hole, I guess? And like what is, I think you in the longer version of the presentation, you kind of talked about what is a meaningful size of a first drill program that you think you have to devote onto a target. You don't want to show up just with 2,000 meters and then you do maybe 3-4 holes and you have to walk away and you didn't test your target fully. So do you have a sense for us, like what is a meaningful program, or when did these discoveries get into those holes that really made it, I guess?
Yeah, so that's interesting. I think I can't remember. It's been a while since I've gone through this myself, but I think it's about 6,000 meters was the median discovery drill program from all of those that I could find meterage on. So, as a metric, 5,000-6,000 meters, I think is a good amount of meters to allocate towards a program.
Yeah.
You always hear a lot of these stories that they hit on the last hole, these kind of things. At Frotet, we hit that intersect on the 7th hole out of a 15-hole program, and that was 6,000 meters. So if we went in with 2,500 meters, we wouldn't have hit it. And I think at the start you have no idea what you're aiming at, and so you just test every combination that you can think of and hope something works. And so I think you really need to put enough meters to give yourself a chance at the start.
Yeah, the other thing that really fascinated me, or I think it's an excellent outcome of the study, is the importance of the thickness. So we see a lot of intersections, press releases all the time where people hit 100 grams over half a meter or 50 grams over half a meter or something like that. And it's a nice number. It's nice high grade, but it's narrow width, right? And I think I totally agree with where you were stressing the importance of thicknesses. And can you maybe elaborate on why you think thicknesses are really important in these gold systems?
Yeah, I mean it's basically tonnage. Because it all comes down to tonnage. If you have significant tonnage and decent grade, it's better than low tonnage and high grade a lot of the time. And then I think like we were talking about a couple of days ago, mineability, obviously.
Yeah.
And so thicker zones or thicker structures are obviously a lot easier to mine than something that's 50 centimeters or 80 centimeters or something like that.
Yeah, exactly. So yeah, I guess in modern times, like if you're trying to mine veins that are they're only half a meter wide or less than a meter wide, and that's all your deposit is made up of, then it's pretty hard to go above 100,000 ounces a year, where you're probably going to be 40-50,000 ounces a year or something like that, which is not bad, but it's probably not a company maker. It's not going to be a world class asset, right?
Yeah.
But if you can have large stopes and you have maybe tens of meter wide zones, then you can be up to 150 or 200 or more, 1,000 ounces per year. So, which is very important. Obviously, we often talk about grade, but when it really comes down to production for the companies, they really want to look at number of ounces per year, right?
Yeah. So obviously high tonnage and high grade is best.
Yeah.
So if
So
you get,
yeah, and it speaks to the probably speaks to the size of the system as well, right? So like you were mentioning alteration halos and the size of sort of the hydrothermal footprint and that sort of thing. And maybe the size of your intersections, like the thickness of the zones, also speaks to the longevity, I guess, of the system, or that it kept opening up, or that it's a really wide fluid corridor or something like that, right?
yeah, and let's say it's a first drill program into a structurally hosted gold target, and you hit, significant width on a structure. What are the chances that you hit the best part of that structure on the first program? Very small, I think. We all know that these are really complicated systems. Nailing down the plunge and what the plunge control can take quite a while to figure out. And so, on initial early programs, if you're hitting 10 meters of, 10 grams, 15 grams per ton, or 15, 20 meters, I think it bodes well for the future, just because it takes quite a bit of time to define a lot of those things.
Yeah. Now, particularly on this, just turning a little bit to this Renault. So obviously your neighbors with Troilus, and not wanting to promote your peers too much, but they are sort of like you said, the 2 million ounce deposit that was already known at the time. So that sort of brought you into the area as well. And so what kind of synergies do you see, I guess, with Troilus maybe? Like, can you draw on the infrastructure that they've already put in place, like road and things like that? So is that, I mean, that to me, that would probably make the project quite attractive when you're exploring in such remote areas. You can probably draw on quite a bit of infrastructure that they already have, right?
Yeah, well, the other kind of surprising thing about the Renault area is it's right on the Rue du Nord, which is
Okay,
a
yeah,
provincial
nice.
gravel highway to northern Quebec. And so we're 3 kilometers off of the Rue du Nord.
Hmm.
So the access is, incredible. There is an access road up to Troilus, but it doesn't really kind of affect us too much. There's a power line that goes to Troilus, but also something that people don't really talk about too much. There's a lithium pegmatite deposit that's 10 kilometers up the road from Renault,
Hmm.
and it was bought by a Chinese company 5 years ago, I think. And I think there's talk about building a power line or extending the power line that goes to Troilus right up the Rue du Nord, right past Renault.
Yeah,
So for this lithium pegmatite,
nice.
and so in terms of Troilus, like that's going down the road a little bit. In terms of engineering and what we can share, what we can't. I have no idea.
Yeah,
It's a
yeah,
bit
but
early.
yeah, I guess just the road, having the road. I mean, it's fantastic. Like it just reminds me of Noron stock. A month ago, Ryan Weston was talking about their challenges in the Ring of Fire, and for them the road is everything, right? So they can't wait for the road to be there, and he's shown us photos of they bring in everything with flights and everything. Like there isn't even a winter road, so they have to fly and everything, and
Yeah, exactly.
so well, yeah, when you selected the areas, do you also pay attention to these kind of things? Obviously,
Yeah,
expedition costs are also a big factor.
we stick close to roads. We've there's some conceptual ideas that we have. We've looked at them, and then it always comes down to like it's 200 kilometers from a road.
Yeah,
It's just a lot more difficult. So it's just easier to stay within decent infrastructure.
yeah. I'm actually quite amazed that you guys were still able to stake this much ground in the Abitibi 3 years ago. Like with online staking, I would have thought that most of this kind of prospective ground would be already taken. So it's Very interesting.
This is why we started the company. Was I was doing some project generation for Orin Resources in Nunavut, and looking around, and I was just amazed at how much open ground there was in greenstone belts, and started looking elsewhere, and it was like, wow, it's all open, you know. And so the
Yeah.
Frotet project, we could have staked 100,000 hectares. It was completely open, but this was, you know, this was a big bite for us. This was 6 months into the company, and we thought that, you
Oh,
know, putting
absolutely.
up
Yeah.
$60,000 was a lot of money at that point, and so we stopped at 56,000 hectares.
Yeah.
But we could have staked the whole belt, and so Troilus had come in and staked a lot around us and south of us,
Yeah.
which was a good idea.
So maybe
And
your timing was still good, because I guess 2017, well, things were already waking up, but it wasn't really this gold market or buzz like we have right now.
yeah, exactly.
Yeah,
Yeah.
it's good on you. Yeah. So yeah, there's a couple questions here. So yeah, like going back to Troilus, so the style of mineralization and geology, like how comparable is it? Is it like can you comment on that, or not
So
really
it's
yet?
early days, you know. So Troilus is hosted on the margins of a diorite in a breccia, and Troilus is gold copper mineralization. A lot of the times it's disseminated within this diorite and diorite breccia, um, and so it's gold chalcopyrite. There's high grade veins. I saw Bertrand was on the call here before. He's the exploration manager. I don't think he's here anymore, but there's probably better people that can explain it than me. But you know, from what I know, there's high grade veins, and they look like they've just remobilized some of this early mineralization into the veins.
Yeah.
There's multiple. I guess there's a couple ideas about Troilus, that it's an early Archean porphyry, because there's a alteration zonation around it. And then there's also an idea that there is later orogenic overprint on top of it. And I think you see it because you see high
Yeah.
grade gold in the veins.
Yeah.
And so that's
Whereas yours
Troilus.
looks more typical orogenic, I guess, from what
Yeah, I mean, that's where we're hosted in a Monzo diorite, you know, kind of intrusive rock along a major east-west structure, which is similar to what you see in the northern part of the Abitibi. You know, that's the docking of the Opatica against the Abitibi at 2700 MA. One thing that's a bit different is the veining is really recrystallized. There's not a lot of iron carbonate. There's a lot of calcite. The metal ratios and trace element geochemistry kind of suggests that there's a magmatic input. So just because there's moly, bismuth, silver, tellurium,
yeah,
and sometimes a
so
bit of cadmium.
but a weird one,
It's definitely a weird one, which is good, I think.
yeah. Yeah. So
So,
there,
you
yeah,
know,
there could be also some thin volcanic, yeah, component in it or something like that because of the high
yeah,
silver, and so it's. But I guess every one of these things is a little bit different. So, what is
yeah,
typical orogenic, I guess?
yeah, exactly. So, I mean, yeah, it's right now it's hosted in quartz veins. We have these longer low grade intervals of, you know, 30 meters of 0.3 grams, and so we're not really sure where the gold is hosted in yet in those low grade intervals. You know, it might be in sulfides. I mean, we see gold is associated with sulfides a lot. We know that there's disseminated sulfides in that interval, and you know, so
Yeah,
we're not exactly sure. But yeah, it's early days. We have low grade disseminated gold. We have high grade structurally controlled gold in quartz veins.
yeah. Just a quick question on the exploration. So, do you know how much you've spent on in the first couple of years before you started drilling on all the soil sampling that you've done and till sampling? I mean.
Yep. So the first program was 450,000, and the second program, off the top of my head, I think it was 1.5 or 1.6 million,
Okay, so
something like
two
that.
million, which yeah, if you compare that into drilling meters, I guess that would be about a 10,000, maybe yeah, maybe 10,000 meters or less, depending on. but yeah, I mean, all that work had to happen to put your holes into the right place. Yeah.
Yeah.
Otherwise, you could have drilled 20,000 meters and not get into anything.
Yeah, exactly. It's all just about the target development to get to
Yeah.
that stage of putting the holes in the right place.
Yeah. Yeah. There's a comment here. So you guys are honest, have energy and focus, which is what probably sets you apart. But what do you think? What else differentiates you maybe from your peers in this grassroots stage of exploration?
Um,
Bit of
I don't know.
self-promotion there.
Bit of self-promotion. Yeah, I don't know. I guess the only thing that I would say is maybe we think big. We're going out and we staked 200,000 hectares out to the west of Chibougamau that we have a JV with Newmont.
Yeah.
And like I was saying, for greenfields exploration, I think you really have to start big because you never know. You might pick the 50 square kilometers and it's probably the wrong 50 square kilometers.
Yeah.
So
it goes
start
back
out.
to a lot of companies have that approach that they go into an existing mineral showing and then they stake whatever 5 by 5 kilometers around it. But like we said, maybe the occurrence isn't anything big and it's not actually in the right place, and you're not really going to know unless you own a larger land package. And I remember actually, like I guess one of the first projects that you picked up wasn't even Frotet. It was the Shikobi, I guess it's called.
Yeah, exactly.
And it's I think it was a very interesting move that it wasn't the belt that was known for its gold occurrences. So I mean there isn't really any large gold deposit there from what I know, but obviously we have the Destor or the Larder Lake Cadillac just south of it. There's Kazabardi Break and Sleeping Giant, whatever else north of it. So I mean chances are this is another big east-west break. It's probably just underexplored and covered in a lot of till, and there will be something there, right?
Yeah, and after we stake the ground, Amex has come out and found new zones along the north side of the Shikobi Deformation Zone.
Yeah,
so
exactly.
It's that really kind of proved our kind of initial thesis when we staked it back in 2016.
Yeah, perfect. Good. Yeah. So I mean, just wrapping up a little bit. I don't know if anybody has any more questions, but yeah, this was a lot of fun. I don't know if you want to add a few things more. I know you got the drill program going, and which you started a couple weeks ago. So good luck with that.
Yeah, thanks.
So what do we? I mean, you have a lot of catalysts coming up this year. Obviously, this drill program, which should test an even larger footprint. So, like you said, it's going to give us sort of the more of the strike extent and really see if that's a 4 or 5 kilometer long mineralized structure, or was there a plume of dispersion halo that you got into, or what that is, and then. So when do you think you're gonna have results of this drilling that you're gonna be announcing? Sometimes in the early summer, or?
I think we just sent the first batch of samples to the lab today, so that would be the first 6 holes. So we'll start getting results. Depends how much we can control the labs.
Yeah, kind of what eight around.
So I don't know. Let's say 2 months. We have something like that. So probably mid-May is when the first results will come out, and then they'll just keep coming after that.
And then that kind of transitions into your Alaska program, right? You said.
Yeah, exactly. Yeah. So once the results come in May, they'll go pretty much till November this year. So it's going to be constant news flow.
Cool.
So that's all the drilling, and then we're working up all these other projects in the background over the summer as well. So it's going to be a busy year.
All right. Well, thanks again for taking the time, and I know it's pretty late over there, so have a good night.
Yeah. Well, thanks for having me. It was pleasure to give a talk here.